All right, here's problem number 8 and 9 from the practice midterm. Says Colin and Rita are both employed by a management company for a very large apartment complex near a major university in the U.S. They have been tasked with estimating the average age of the residents in the complex. Colin takes the random sample of 35 residents. Rita, who has a little bit more time, takes a random sample of 65 residents. Question 8, Colin and Rita decide to calculate a 90% confidence interval for the mean age of the residents in the complex. Again, the idea is that they're doing a sample so they don't have to contact everyone in the residence. And then when they do so, they get an estimate, and then we can find out with 90% confidence a range of values that you think that the true mean would lie. Consider each the statement and identify which ones of them are true. Rita's interval is more likely to contain the true mean than Colin's because it's a larger sample. That statement is false. And it's false because they're both doing 90% confidence intervals. The two intervals have they have equal confidence in them. Procedures like that will be right 90% of the time. Question or item 2, Rita's interval will be narrower than Colin's. That is a true statement. Please note that again the formula for this kind of thing is S over root n. Okay, and because you're dividing by the square root of the sample size, it's likely that that number, as n gets bigger, this whole thing, the margin of error gets smaller and smaller, resulting in a narrower confidence interval for Rita. Will Rita use the same T star? The answer is no. T stars are based on degrees of freedom. Rita has degrees of freedom 64. And if we're doing 90% confidence interval, that means there's 5% in this tail. And we would find her T star value by saying inverse T with 5% in the tail and 64 degrees of freedom. And so her T star value is negative 1.66, whereas Colin's has 44 degrees of freedom. And with 44 degrees of freedom, you're going to see a slightly larger T star value. So this is not true that Rita's T star value is the same. So it looks like the only answer that's correct is Roman numeral 2. All right, question number 9. Rita's 90% confidence interval was that. Which of the following is not a correct interpretation of the interval? Now remember, the idea is the interval captures the true mean age for everyone at the complex. So Rita can be 90% confident that the true mean age of the residents of the complex is in there. That looks like a true statement. That's a winner. Rita can be confident that the residents are between these two ages. That is an incorrect statement. Okay, the statement about the confidence interval is about the mean, not the individual values and its distribution. And then 3, if Rita collected 50 different samples and constructed 50 different 90% confidence intervals, she'd expect 5 of the intervals that would not contain the true mean age. Okay, well, if you did 50 times 90% is 45. 45 of them would be expected to capture the true mean, and that means 5 of them would not. So number 3 is correct. So the correct answer here is 1 and 3. All right, question number 10. The owner of the complex decides to combine the data for Colin and Rita into a single database. After doing this, the standard error of the sample mean age is 4.33. What is the most appropriate interpretation of that standard error? Well, let's do a quick review here. Standard deviation of the sampling distribution of X bar would be sigma over root n. And this is the average distance of X bar to the population mean mu. Now, when we have a standard error, it means that instead of using sigma, we use S. And the only difference is that this thing called the average distance becomes the estimated average distance of our X bars to our mu. So the standard error, again, is an average distance and is measured in the same units as the mean. So in answer A, they're changing 4.3 and changing into percent. Well, percent is not the same as the years. That percentage there and there make those answers incorrect. In repeated sample, the owner can expect the sample mean to be on average within 4.33 of the true. And that looks pretty good because it talks about the average distance within distance, okay? And then, so B looks like the right answer. And then this where they're doubling it is probably inappropriate because depending on the confidence level, you're going to multiply by 2 or a little bit more or a little bit less. So the correct answer there is B.